Hey folks, welcome back. We are doing some dynamics problems. We're into chapter 15. We're in I guess this is the third block. We're looking at acceleration in the plane. So this problem should look a bit familiar. This is our friendly neighborhood crankshaft example. And we've done this a couple of times. So previous times we found that given the initial rotational velocity, omega, of 209.44, that the corresponding omega for the bar BD is 62 radians per second in the anti-clockwise direction, right? So the positive direction, and that beta is 13.95. So here we're asked to find alpha of BD and the acceleration of BD. And in order to do that, we are going to use the long equation, right? So what is the long equation? The long equation is this. It is AD, which is what we're after. It's going to be AB plus, and there's three ways to write this. And I'm going to write this in the final form here, and then I want to simplify it a little bit and show you this. So this would be the way to write this, by the way, is RDB. And I'm going to come back in just a second and talk about what that means. This is our omega squared, and here I'm going to say this is BD. So this is a relationship vector, and what it means is if this is D and this is B, then the D is where you're going and the B is where you started. So it's here, right? So that's one way of writing it. The way that I prefer to write it, so that I don't get lost in there, is just with the initials of the points, right? So BD, and that tells me where I started from and where I'm going. So this is BD. It means the same thing, but for me it's a little bit easier to see. So clearly, in order to, backing up, I did say I wanted to show where this comes from. This, again, is A sub t, right? Cross product. And then this is A sub n, right? And we remember this from v squared times rho. So, then we could rewrite this, right, as A, D, B, right? And we'll see that as we're working through it, but that just gives us a sense of, where these come from. So, in order to solve this, we're going to need the acceleration of B, right? So, starting from a quick free body diagram of that crankshaft AB, where this is A and this is B, we have a velocity here of 209.44. So we'll just say omega AB, right? And our velocity VB is equal to the cross, right? So omega AB times the velocity. I'm not sure if I need that though. All I'm looking for is the acceleration. All right, long day. So the acceleration of B is actually just equal to these guys, right? Because A isn't moving, right? So I don't need the A sub A. A sub A is 0. Okay, so we are given that the acceleration is constant, so that this part doesn't exist, and so we have omega squared times BD. Omega squared is 209.44 squared, and BD is, or excuse me, it's not BD, this is AB in this case, and this is 3, right? And so this is 3 inches, and I'm going to convert all of the lengths to feet to keep the numbers under control, because as you can see, this is going to get to be quite large. So when I multiply this out, this becomes let's see, move this over here, we'll say A sub B is equal to 10,962 point, wait for it, let's see, let me just do it again to make sure that I don't mess this up, squared times 3 divided by 12. I said I didn't want to screw it up, and what did I do? I pushed an extra button. Okay, so 10,966.3. So I'm just going to go 10,966. Okay. And that is feet per second squared. Okay, so that checks that off, right? That gives us this. Okay. And we need to think about alpha and BD. So what is BD? So we've got this bar, and what we're going to end up needing is this, these structures again. So here, by the way, this acceleration is in the normal direction, right? So AB is in along the normal axis. So that goes that way. So that's AB. AD, it looks a little funny at first, so it looks like this. All right, so this is A sub D. And the reason is because there's no way to know which, based on the equation that we're given, there's no way to know which direction AD is going to face. Right, so AD equals, and then here we're just going to do the translation rotation thing again. Right, so these are both A sub B. Right here and here. Okay, and then plus, and now we have a hammerhead looking guy. It's going to be this guy here, and this is A, and the way that they give it to us is AD with respect to B, and this part is clearly the tangential direction. Then there is the normal direction as well, right? So I'm just going to say A sub n here, that guy. And so then either there's going to be a resultant, right, where you add these up. And so these are, one of these is going to be our acceleration of d with respect to b, right? Because we've got some sort of a alpha here. We just don't know which one. So what we can do is we can actually use the same triangular method that we used in, oh geez, let me make that a little bit smaller so you guys can see it. There we go. Okay, sweet. Sorry about that. All right, so this AD, one direction or the other, but check it out. A sub B goes this way. All right, so that's A sub B. All right, and since A sub D is the sum of this plus these guys, well, that means that this would be A sub n, right, with beta being right there. Hello, beta. And this is A sub t, right? And again, beta making an appearance. Okay, then if this here is 40 degrees, as we see in the diagram, then this right here is also 40 degrees. Cool. All right, and then what? Then we need to look at the omegas. Okay, so what we can do is we can start calculating the a sub n, a sub t, right? And let's see, which one do we want to play with first? Let's look at a sub n. Okay, so a sub n, that is omega squared bd. And for the time being, I'm going to leave these as just numbers so that we can do these calculations, because it's going to take a second to untangle the I and j components. We'll do it, but let's just wait a second. And so what is this? This is 62. So this is 62 squared, and then BD is 8, right? So 8/12, right? So A sub n is equal to 62 squared, say divided by 12 times 8 gives us 2562.67. And let's go ahead and make this directional, right? So this, we're going this way, right? That is our angle, and that is 13.95 degrees. Okay, so then similarly, a sub t, what is that? That is alpha cross, and this is k, alpha cross r, and r is BD, and BD is 8, right? So we're using, remember that we're using the feet, right? So it's 2/3. So alpha sub t is 2/3 alpha, and which direction is this? This is the t direction is going this way, so it's like that, and that is 76.05 degrees, right? And so we have our three values, right? We've got a sub b, we've got a sub n, and we've got a sub t. And what we can do is we can now put them together to solve. Right, so are we going to have enough room here? Let me look at the whiteboard. We're still... I keep moving the diagram out of the way for us. Okay, so what I'm going to do is write these values up here, and then I'm going to erase this so that we can just do some algebra, essentially. So a sub n equals 2562.67 in this direction. That is 13.95 degrees. A sub t equals 2/3 alpha, and that is in this direction, 76.05 degrees. Okay, and now let's erase some of the stuff out of the way and just put this equation together. Alright, so let's see, there, and I almost want to use a different color, but unfortunately if I use a different color and I write too much, then it ends up being crazy on the eye. So let's go in the I direction first. Well, wait, hold on. So recall that the acceleration, because of the orientation, the limitation of the movement of d, the acceleration has to be in the I direction. So let's solve the j direction first, because that's going to equal 0, right? So in the j direction, our acceleration, so acceleration in the of d in the j direction is 0. So 0 equals, and then this is, let's just do this. I'm going to write it out this way. ABJ plus alpha, yeah, I'll come back to it. So 2/3 alpha, yeah, that's going to take a second to get through. Let's just do it symbolically first. So this is a sub t in the j direction plus, I guess, minus a sub n in the j direction. Well, plus is a minus, so this is plus and that's a minus. Okay, so what do we got here? The j direction for this is, so this guy is this way at 40 degrees. So the negative here would be this much times the 40 there, so times the sine of 40 degrees, so 10,966 times the sine 40 degrees, and that is equals minus 7048.81. Okay, and then plus, and this is there. This is 2/3. So 0.667, and that is in this direction here. So we have our theta is there. We're interested in the vertical, so that is times the sine. So 0.667 times the sine of 76.05 degrees is 0.647 times alpha, and then our a sub n is, we're in the j direction, so this is still positive, and it's this much times the sine of that, right? So 2562.67 times the sine of beta, which is 13.95, and that gives us 17.796. So alpha is going to be this plus this divided by that. So that gives us alpha equals, let's see, 7048.81 minus 617.796 is that divided by 0.647, and that gives me 39.74. So I'm going to say that that is 9940 radians per second squared. Okay, and let's see, is that positive or negative? So we are rotating this way, so that is a positive value. Okay, sweet. So that is the first thing that we need to find. So far so good. Alright, now in the I direction, which is where we'll be able to solve for the acceleration of d. So in the I direction, what do we have? We have AD is equal to the I components of these things, right? So now, instead of this being the sine of 40 degrees, it's cosine. So 10,966 times the cosine, oops, didn't push the button hard enough here, times the cosine of 40 degrees. So that is minus 8400.44. Then we're doing what, the a sub t. So now this is 0.667 times the cosine of 76.05. So 0.667 times the cosine of 76.05. What is that? That is plus 0. I'm going to say 1608. I'm going to say that and apparently try to write down something different. 1608. And, oh, that is times alpha, so I just plug that in. So I'm going to say times, oh, that guy there. Oh, excuse me, hold on. Okay, and I got, when I multiplied that through, I got 1598.28. Okay, and finally, our a sub n, which direction is that going? That is going against us. So this is a minus against us. No, that's not how any of this works. Okay, so a negative 2562.67 times the cosine of 13.95 degrees. So let's say 2562.67 times the cosine of beta. So that is minus 2487.09. So if I add these up, what does that give me? Should be able to do this, right? That and minus that plus that, and that gives me, I get 9289. So I'm going to say 9290, and this is linear, so feet per second squared. And I believe that coincides with my notes. 9290, look at that. Sweet. And recall that we discovered that we're going that way because we have to, right? Because a sub b. So a sub d, it's this guy here. Okay, and we pulled it off. Sweet. Well, I hope that was helpful. Keep in mind, as you're doing these, we calculated all of this based on having already calculated the angular velocities for the system in two different ways, right? So to start from zero and do this problem would take a little bit longer, but that's okay because it's good practice. So anyway, I hope that was helpful, and I will see you in the next video.